Walk into almost any modern office, and you will find them tucked away in the corners. They often blend into the background, obstructed by delivery boxes or furniture, remaining ignored until a crisis begins. Many people operate under a psychological blind spot, assuming that simply mounting a cylinder on a wall satisfies the requirements for building safety. A fire moves with terrifying speed, doubling in size every few moments during the critical first 60 seconds. In this narrow window, every second spent searching for a clear path to an extinguisher reduces the likelihood of containment. If a fire breaks out in your current room, the physical architecture of the space and the precise location of the nearest extinguisher will dictate whether you suppress the flame or become trapped by it. These devices require strict adherence to architectural placement standards to be effective. Without these specific spatial rules, the extinguisher remains a heavy, inaccessible weight on the wall. Fire safety standards, such as those from the NFPA and the Bureau of Indian Standards, govern placement through a metric known as travel distance. Travel distance is the actual walking path around obstacles to reach an extinguisher. For Class A fires like wood, maximum distance is 23 meters. For Class B flammable liquids, it's 15 meters. For Class K commercial kitchen hazards, the distance is slashed to 9 meters. This precise mathematical equation creates a critical survival window, pitting the specific growth rate of a chemical fire against the time it takes a human to walk to the equipment. Once you reach the extinguisher, you must be able to deploy it. Therefore, the unit's top cannot exceed 1.5 meters from the floor, ensuring the heavy weight is manageable for anyone during a panic. Strategic placement requires mounting extinguishers strictly near exit routes, such as main doors, corridors, and stairwells. Consider this layout. If an extinguisher is placed at the back of a dead-end room, you are forced to run away from the exit to retrieve it. By the time you turn back, the fire has grown, blocking the only way out. Chemical compatibility is the next requirement. Kitchen environments specifically require wet chemical extinguishers to neutralize high-temperature grease without causing a splashback. In an electrical room, water-based agents can conduct electricity back to the operator. These zones require CO2 or clean agent extinguishers to safely kill the fire without creating an electrocution hazard. Proper spatial installation engineers a safer response, ensuring that as you move toward the equipment, you are also moving toward the exit. Imagine a building with a perfect audit. The distances are exact, the chemicals match the hazards, and every unit is mounted at the correct height near the exits. Even in this scenario, the system fails if the person holding the device freezes because they have never been trained to operate it. To bypass emergency panic, training relies on the PASS protocol. First, pull the pin. Next, aim the nozzle at the base of the fire, the fuel source. Squeeze the lever to discharge, and sweep side to side to blanket the hazard until the fire is suffocated. For this sequence to work, the cylinder must be pressurized. This requires mandatory monthly visual checks and annual professional maintenance. Reliable protection depends on the combination of spatial geometry, regular maintenance, and trained human action, all synchronized for the moment a spark catches.